So here's an example of a pointer question which I might ask on an assignment or on an exam. Here we're given some initial information about where our variables are stored, and we are also given some code. So when tracking memory, I like to use the pictures like this. So if I have a variable, I would write the variable's name, and then I draw a box. On top of the box, I write the variable's address, or the variable's memory address. And then inside the box, I write the variable's value. And then if I have a pointer pointing at that variable, then I can also have a pointer holding the same variable's memory address, and I can use arrows to show where our pointers point. So I encourage you to use the following strategy for solving pointer problems. First, you want to make sure you draw all the variables and label the values and memory addresses either using my convention above or another that makes sense to you. And then you can read through the program and update your pictures to track what is happening. And finally, remember to refer to our pointer rules to remember the use of the asterisk operator, equal sign, and other key operations. So with this strategy in mind, let's go ahead and try solving the pointer question shown here. So if I were to solve this question on a homework assignment or an exam, this is how I would do it. Notice I'm given a lot of information about A, B, C, D, E in the beginning of the problem. So I'm going to go ahead and make an area in my workspace here. This is my main function. And in my main function, I know that my variables A, B, C, D, and E are declared inside main. So following my naming convention, I'm going to make my variable A, give A a box where I can put the value. And A is stored at memory address 1000. So I write my variable A like this. Similarly, my variable B is stored at address 2000. Variable C is stored at address 3000. Variable D is stored at address 4000. Oops. So notice I'm just putting the memory address for that variable on top. Since D is a pointer, I'm also going to put a little asterisk next to it, just so I remember that D is a pointer rather than a regular int. And finally, my variable E, also a pointer. E is stored at memory address 5000. So I went ahead and, since I know that this memory is all being allocated by main, I went ahead and drew those boxes. Now that I have drawn the boxes to hold my variables A through E, I'm going to start reading through this program line by line, and I'm going to update my drawings. As I read the program line by line. It can often be helpful to use different colors while doing this, so consider having different colors available. First line of code, I say int a equals 2. So I go to my a variable and I assign it the value 2 inside its box. Int b equals 60, so I go to my variable b inside my memory and I give it the value 60. Int c is 200, so I give c the value 200. Look what happens with d, though. D is a pointer. And I'm declaring my pointer D, but I'm making it point at a new int. I am told memory allocated on the heap using new will be stored at address 8000. Remember, since D is a pointer, D is going to hold the memory address 8000 where the new int was created. So notice here, my pointer D is going to be pointing to that new int. Asterisk D equals A. Well, notice what this line of code will do. I'm going to go where my pointer D points. That's this new int. And I'm going to assign that the value stored in A. So here, I'm going to assign D's new int the value stored in A, which is 2. Finally, int star E equals ampersand B. Remember, that's the same thing as declaring our pointer E and making it point at the memory address of B. Essentially what we're doing here is we're taking E and making it point at memory address B. That also means that our pointer E is going to store B's memory address. So E is now holding B's memory address and pointing at our variable B. All right, in the next line of code, we are calling the function mystery. So notice mystery is the function shown here above our main function. Remember, we do not actually run the code in mystery until it is called. But here, we're going to go ahead, and since we've called mystery, we're going to exit our main function and enter mystery. So when we're inside the mystery function is going to have its own variables, a, b, and c. So notice the variables a, b, and c are local to mystery. And notice that d is going to be plugged in for a, c is going to be plugged in for b, and my variable b in main is being passed by reference into c. So let's update my mystery variables a, which is a pointer, b, and c, with the values that we passed in when calling mystery. So notice in main, my variable d was a pointer that held the memory address 8000. So that means in my mystery function, I'm going to plug in d for my variable a. So I'm going to copy my value 8000. And now my pointer a is also going to point at memory address 8000 where d points. Because remember, both a and d are pointers, and they both are holding the memory address 8000. So since I plugged in d's value 8000 into mystery, that is how we both point at that new int 2. The next value we substitute into mystery is the value c in main, our variable c. So in this case, c is just an int. So we're plugging in our variable c in main into our variable b in mystery. So we take the 200 stored in c and we plug it in to the 200 in mystery, or to variable b in mystery. Finally, this last one is very important. I'll use a slightly different color here just to illustrate what's happening. Notice that this variable b in main is being passed by reference into mystery's variable c. So what I'm going to do here is I'm going to put a note so I remember that this is pass by reference. Oops, and I drew the arrow incorrectly. Notice I'm plugging in my variable b in main into mystery as variable c. So mystery is going to receive that variable 60, but any changes made to c by mystery will also change c, or I'm sorry, variable b in main due to pass by reference. So it's helpful to note that in your picture so that you remember. So when I call that mystery function, I'm exiting main, entering mystery, and I have plugged in a, b, and c into my mystery function. I can now run the code inside mystery and track what happens in my mystery function. First line of code is C++. That is the same as writing c equals c plus 1. So that means this variable c is going to be incremented to 61. But because it's passed by reference, variable b back in main is also going to be incremented to 61. Next line of code, we have b minus minus, so that's 200 equals 200 minus 1. So our variable b is going to be decremented to 199. Next, asterisk a equals 3. So remember what that means is I'm going to go where a points. So I'm going to go where pointer a points and update that value to be 3. So because my pointer a was pointing at memory address 8000 back in main, that pointer a can go in and change my data inside main to store the value 3. Now I have a cout statement. I'm being asked to output the address stored in A, which is the A in mystery. So I'm sorry, not the address stored in A. I'm supposed to output the value where mystery's A points. Mystery's A is pointing at 3. Next, I'm outputting mystery's variable B. B contains the value 199. Finally, I need to output my variable C. C inside mystery contains the value 61. Finally, mystery is going to return the value where A points, which is 3. But I don't give mystery any variable to return A2, so that return value is just going to be thrown away. No one is there in main to receive it. Finally, at the end of my program, I have some additional cout statements. Notice now the variables I'm outputting in this set of cout statements are the variables local to main instead of the variables that were in mystery. So here if I output A to the screen, that will output the value 2. If I output B to the screen, that's going to output 61. Remember, because of pass by reference, changes made by mystery still affected the changes in B. Or the changes made by mystery still caused B and main to be changed. If I output C to the screen, I'm just going to output that number 200. And if I output D, notice D is a pointer. So if I output whatever's stored in D, that's going to be the memory address, 8000. And if I output E to the screen, E is another pointer. And remember, E is holding the memory address where B lives, so E will output the memory address 2000. Last line of cout statements, we have cout ampersand A. That's the memory address where A lives. That will give us 1000. Ampersand B, that's the memory address of B. That's 2000. Ampersand C is memory address of C, which is 3000. Asterisk D, remember, that is the value that D is pointing at. D is pointing at the number 3. And our pointer E, asterisk E, means to return the value that E points at. E is pointing at our variable B, which holds the number 61. So asterisk E will output 61 to the screen. So there you have it. You can see that these drawing problems might have a lot of steps and a lot of things to keep track of, but they're really great practice to make sure you truly understand how pointers work. So please make sure you take the time to go through this example on your own and verify that you can get the same result that I did.